Hello everyone. In today's video, we're talking about systems of equations, but we are talking about special cases when it comes to systems of equations. So let's take a look at the three potential scenarios. The first one is the one that we're used to, where when we solve it, we'll get one answer. So when we solve it, we'll find out what x and y are, and we have their coordinates. Now that solution corresponds to the intersection of the two graphs. So normally when you first learn system equations, it's two linear equations. In the future, you guys might be doing two quadratic equations or one linear, one quadratic. Any solution that you come out with will be the intersecting points of the two graphs. Second case that can happen is that, again, when we're learning about the linear scenarios, that the two lines end up being parallel. If the two lines are parallel, that means that there's going to be no solution to this system, which means that there's no intersecting occurring. And we're going to take a look at an example later of how this can happen, or how do we know this is this case that's happening. And the third case here is that there might be infinite solutions. So for example, we'll have two lines, however, that they might look different in equation, but in actuality, they're actually the same line. And what's going to happen is that one line is going to be just like a shorter version of an extended version of itself. So therefore, you can see here that if we took the two lines and we overlap them, because they're essentially the same equation, you get that they actually intersect infinitely many times. So they overlay on top of each other. So again, we'll take a look at a system that does this, and that's how we're going to figure out there are infinite solutions. So to recap, you have one solution, no solution due to parallel lines, and infinite solutions when the equations actually turn out to be the same thing. So let's take a look at an example. So in this one here, we can see here that we have two linear equations. Now, we can take a look at how they're set up, and if you take a very close look here, these two equations actually set up in such a way that, so we'll call these 1 and 2. So I take the first equation and I multiply it by -2. If I do that, you'll see here that we actually end up getting 6x minus 2y equaling to 2. So this actually matches equation number 2. So if we ended up showing that they're actually the same and we did elimination, we'll end up getting something like this. Where if we had 6x minus 2y equaling to 2, then we would subtract the other equation, which is also 6x minus 2y equaling to 2, and we'd actually get up 0 equal to 0. When 0 is equal to 0, this is a true statement. A true statement basically tells us that there are infinite solutions. And this is how we tell. If you can tell right away that they end up being the same equation, great. That means they're the same line, and therefore there are infinite solutions. If you run through it with substitution or elimination, and you come to the conclusion that 0 is equal to 0, then again, if that statement is true, that means that there are infinite solutions. Now let's take a look at this one here. Again, we'll call this equation 1, equation 2. Now for this one here, again, I'm going to double equation 1 just to see what happens, because I can see that there's some kind of relation between the two. So double of 1 will give me 4x plus 6y equaling to 10. I'm going to call this guy equation number 3 because it's different from 1 and 2. I'm going to take 3 and subtract it with 2. So I'm going to go 3 minus 2. This will show us that's 4x plus 6y equaling to 10 minus 4x plus 6y equaling to 8. Now the reason I put minus with a circle around it is to remind myself that I always have to come back to it every time I do a subtraction. For example, 4x minus 4x, that's 0. 6y minus 6y, that's also 0. And then 10 minus 8 would give me 2. See, in this situation here, we have 0 equaling to 2. This here is a false statement. Right? We know that that is impossible. So if it's a false statement, that means there are no solutions. And if we were to graph this, you would see that there would be two parallel lines where they start at different places, hence there are no intersection points. So I hope this video helped clarify the type of different unique cases that can happen when we're solving a system of equations. Make sure to like the video and subscribe to the channel. It would mean so much to me. Thank you so much for watching, and I'll see you in the next one.